So for chapter 4, page 124, number 52, we have a helicopter and it's moving horizontally to the right at a constant velocity. It tells us the weight of the helicopter is 53,800 newtons. So we can actually kind of incorporate that right here. The weight is 53,800 newtons. Now, one of the key phrases in this whole problem is the fact that it's moving at a constant velocity. Constant velocity means that the acceleration will be 0, which means the net force in the x is going to be 0 and the net force in the y is going to be 0. So that's going to help us out a lot with this problem. So back to the problem. So we know that the weight is 53,800 newtons and there's some kind of wind resistance force acting along the x and there's a lift force acting at an angle. So a good way to do this is to actually break this lift force into its x and y components. So we have the x component of the lift pointing this way, and we have the y component of the lift pointing to the right. Let's find an appropriate color. So we break up that lift force into its components. Now, since in terms of forces, we only have one real force acting on the x. We have the r and the x component of this L. And then in terms of the y, we only have the y component and the w. So we know that they're going to have to cancel out. So that means that the y lift force minus the weight has to equal 0 because the net force in the y has to equal 0. So that means the lift y minus 53,800 newtons has to equal 0. So that means the lift in the y direction has to be 53,800 newtons. So we found our lift in the y direction. Now, if we look at the same thing in the x direction, which we'll make blue, since the net force in the x direction has to equal 0, and the only x components are the lift in the x direction minus the wind resistance force has to equal 0, that means the resistance force has to equal the x. But the problem is I don't know what either one of them is, so that's not as helpful as I had hoped. Now, how do I find out what the lift force is? Well, if I try to draw a right triangle of this part right here, we have the lift force. So I can draw a better line than that. We have the lift force acting on a 20-degree angle. And we know that the y component is 53,800 newtons, excuse me. So how do we find the x component or even the lift? So if we look at this like a right triangle, we can use our trig. We can say now in terms of this angle here, I know the adjacent. This is the adjacent, and I'm trying to find the hypotenuse, so I can use cosine. I know that cosine of 20 degrees is going to equal my adjacent, which is 53,800, divided by my hypotenuse, which is the actual magnitude. So then I get L cosine of 20 is equal to 53,800 newtons. And then I divide both sides by cosine of 20, and I get L equals 57,252 newtons. So I find my L. Now the next part of the problem says, what is the R going to be? So now we found out that the R is equal to the x component. It's just pointing the other direction. So really the next part is trying to find my x component here. And that's like on the purple here. So we're trying to find the force in the x direction. Now the way to find force in the x direction, we're trying to find the opposite, because this is the opposite. And we know everything, but we'll stick to our adjacent, so we can say that tan of 20 degrees is equal to our opposite, which is our force in which is our L in the x direction, divided by our adjacent, which is 53,800 newtons. So we multiply 53,800 newtons to both sides, and we get Lx is equal to, so 1020 times 53,800 gives me 19,581, which is also what our, what did they title it again? Which is also what the R was in this problem. So the R must also be equal to 19,581 newtons, just pointing in the opposite direction. We could have solved this also using, because we knew all the sides of the triangle, we could have solved this also using sine. We could have said that sine of 20 is equal to the opposite, which is the x component, over the hypotenuse, which is right here, 57,252. And we would have found out that Lx is still equal to about 19,581 newtons. So we would have gotten the same answer either way. So there we have it.